Hello everyone, how are you? How are you all?
Good, Palak.
Yeah. Hello Harsimran Kaur.
Hi,
Hi, how are you?
I'm fine. How are you?
I'm good too. I guess we'll wait for 2 to 3 minutes more and let's see if more people are coming in and then we'll start with the session then.
Okay.
Any of your friends or colleagues who have registered and who want to attend this session, please make sure you send the links to them too and ask them to join fast so that we can start early. I would like to ask if anyone of is can use a mic and give us their introduction. We'd love to hear you all. You can take that up.
Okay, let me start with my intro. Uh,
Yeah, that's
I'm,
great.
Pi- I'm Piyush Agrawal. I'm part of Next Wave Hive as a volunteer. So we organize this event with respect to marketing and operational stuff and lot of things we are doing with Next Wave Hive. You will get to know. Palak will explain you all the details in next 15-20 minutes. But love to connect with you all. And we'll share the LinkedIn details also during the event. And you also can share your details. We want to connect with you and
Yeah,
let's see.
definitely. Yeah, let's share our LinkedIn's profiles and connect with each other actually.
So we can start with few other members. Rohit, we can start
Yeah.
with you.
Yeah, go ahead,
Uh,
Rohit.
Hi everyone. I'd just like to say that I'm not turning on my camera because I'm at home and it's not really a nice background, so I'm not doing that. I'm really sorry for that.
It's all right. It's all right.
Now, a bit of background about me. So, my expertise, I'm a biomedical engineer by education, and by experience, I am a regulatory professional and a product development professional. Currently, I'm a senior consultant at Factor. Me and when it comes to Jen, he has been a very valuable colleague of mine and a dear friend. And
Yeah, heard about you from him.
yeah, and I have had the pleasure of working with him during some of the most interesting projects I've ever had at my life. And
Yeah.
so I'm here. And next wave sounds really interesting, and I'd love to see what you guys have. Thanks.
Thank you. Yeah. Harsimran, would you like to introduce yourself?
Hello. My
Hello.
name is Harsimran Kaur and I'm engineer in electronics and communication.
Okay.
Presently, I'm not in IT sector. I would like to go there someday, maybe. But right now, I'm in working in a printing firm as a designer, and
Okay.
that's it. Thank you.
Yeah. Good that you are exploring. I guess we can start with the session now. Uh,
So
Before
people
starting the
are,
session, yeah.
lot of people are left. Kiran, Urvashi, they can go ahead with your
Yes.
introduction.
Okay, yeah, we can take their introduction to them. Yeah.
Kiran?
Vami Krishna or Kiran,
Yes.
any one of you, if you would like to give your introduction.
Yeah, hi, this is Kiran Kumar Reddy. So,
Yeah.
like, I completed my graduation, like BTech in the ECE. So, currently, I'm working as a firmware engineer in a startup company which is located in Bangalore. So, I get to know about this event. Like, I have a LinkedIn connection with Jayan, so he shared this post. So, there I found about this event. So currently I'm working
Mm.
into the same sector, firmware engineer. So I wanted to explore more about these STM32 things, which is above my head, like whichever the things I don't know. So I wanted to explore those things. That's the reason I registered for this event. Thank you.
Yeah, good to see your enthusiasm and thanks for joining. Uh, Vami Krishna, would you like to introduce yourself? Rohit or Vishi, any one of you?
Hi, ma'am. Good afternoon.
Yeah, yeah. Hello, hello, sir.
I have worked with Jain sir. He is my senior. When I was in a Panacea Medical
Okay.
Technology,
Mm.
I like he only shared the link. I want to get some knowledge regarding the embedded system, so that I have joined this call. That's all, ma'am.
Palak, you are there? Okay. Venugopal, we can go ahead with you. Am I audible?
You, all of you can actually use the chat and share your LinkedIn profiles actually, and we can all connect with each other. And if possible, I would say that if you can on your cameras, that would be even better. It's good to look at the faces, and we feel that even if we are on a virtual session, yeah, every one of us is still there, and yeah, that would be great.
Palak, we can go ahead now. Palak, I guess we can go ahead now. If someone join, they will follow. Palak, I am audible.
Yeah, yeah, Piyush, you are
Palak,
audible.
are you there?
Also, you all can follow us on our LinkedIn, Instagram, as well as join our WhatsApp community so that you'll be updated because every time we try to bring a session to you,
Palak, are you able to hear us? I guess some lagging is there from your side.
let's all actually get together and grow together. I would like to say that also. So please do that too until we start now with this session. I hope I am clear now.
Yes, yes, Palak, go ahead.
Piyush, you are muted.
No, no, I am speaking. Palak, are you able to hear us? Let me call Palak. Palak, you need to change your mic
Okay,
headphone.
then before we start with our session today, I would like to say that and introduce you all to our community actually. So, yeah, before starting that, I would like to introduce myself first that I'm Palak and I'm actually enthusiastic about electronics and AI. Otherwise, I'm a passionate learner, but still a curious child who loves questioning at heart. So that's about me. Yeah. Am I audible, guys?
Yes, yes, Palak, you are audible, but are you able to hear us? Okay, some issue with mic.
Before starting, I would like to know that am I audible enough, or is there some network issue from my side?
Okay, let's wait for 1 minute. I'll inform her.
Am I audible now?
Palak, you are audible, but are you able to hear us?
Yes,
Yeah,
you are audible.
now I'm able to hear you.
Yeah,
Sorry
because
for the
that is
inconvenience.
a one-way communication going on.
Yeah.
No
So
issue.
sorry for that.
No issue. You can go ahead now.
Okay then. Okay, let's get started then. My screen is visible, Piyush?
Yes, Palak.
Yeah, sure. Uh, so I would like to introduce myself first. So I'm Palak Toshniwal, and I'm a passionate learner, and I'm enthusiastic about electronics and AI, as well as but otherwise I would just sum it up saying that I'm still a curious child in my heart who just loves questioning. So and as that I'm still and because of that I'm also here too. So I would like to first thank each and every one of you who have joined this session. Thank you so much, so that on the part of whole Next Wave Hive community, I would like to thank you all. Let's actually, I hope that we have put in our best efforts to make your weekend worth it, and uh, you go back with all the wisdom that Jayant is here today to share with us. So yeah, now I would first like to introduce you to our community, that is Next Wave Hive. What actually it is, why should you join, and what we actually offer. So all of it in quick few minutes. So, Next Wave Hive, it's a space where curious minds, bold ideas, and collaborative energy come together. As our vision says, innovate together, transform forever, and we mean every word of it. Now, let's talk about what Hive actually offers. For anyone with passion to grow, whether professionally, this is technical or non technical, or personally, Hive becomes your partner. You get access to mentors who guide you, incubation support if you are working on any startup or any idea, they let you build. And if you enjoy meeting like minded people, our networking events and weekly sessions like this one will be your favorite place to be. Now, what let's talk about what Hive actually offers. For anyone with a passion to grow, whether professionally, that is technical or non-technical or personally, Hive becomes your partner. You get access to mentors who guide you, and incubation support if you are working on startup or any idea, and hands-on workshops that don't just teach you, but they actually let you build too. And we have many events like this. We usually host them like on bi-weekly sessions, and we try to deep dive into new technologies, what are their advancements, or some live demos into them, so we all get like an hands-on experience. So Hive. The one thing that I personally love about it is how inclusive it is, and you don't need to be, like have some big titles or years of experience to be heard here. You can be a student, fresher, professional, or just an enthusiastic learner too. If you have an idea or something to share, this platform is all yours. Whether it's a new tech demo, a product prototype, a talk, or an idea that you have always wanted to give, we would welcome you to be a speaker, and you can reach out to us on our website or through our email. We'll want to be the cheerleaders of each one of your journeys and make it happen. So, what do you actually get when you join Hive, and why to choose Hive? You get to build meaningful connections, learn from others, and grow your own skills. You'll find mentors, peers, and opportunities to present your work to the world. And most importantly, you will become part of this thriving, uplifting community that helps and celebrates you for who you are and what you bring. Well, looking ahead, our goal is to expand across industries and globally. We plan to introduce new tools, more learning opportunities, and support systems for anyone who's ready to turn an idea into an impact. Hive is not just a place, it's a growing movement of creators, leaders, and dreamers like you. And if you're someone who would like to join our mission of creating this impact, you can grab this opportunity to be a volunteer. We'll share the Google form, and it will hardly take 1 or 3 minutes, where you can choose your role according to your skill set. You can share your skills, help with events, lead new initiatives, and it's a great way to build your confidence, gain experience, and meet amazing people along the way. Every small contribution of yours will help us to build Hive bigger, greater, and stronger. You might be wondering, like, this sounds great, but how do I join? It's simple. Whether you're a professional, student, fresher, startup founder, or just exploring, as I mentioned before, you are all welcome here. Just head to our website and sign up, or join our website. Join our WhatsApp community, LinkedIn, or even we are present on other social media platforms. From there, you will be part of our events, workshops, and community, and you will get all the updates to stay, know what is happening actually, and what, how, and when can you contribute, and you can join the sessions, and we all can learn together and grow together. So as we always say, that we are not fortunate and about the destiny, but we can all be part of each other's journey, and journey is something that we all should enjoy, and we should progress along the way. So we would like to do that with all of you, and let's do it together. So over the past few months, Hive has hosted some incredible events. We have had brilliant speakers, live demos, and interactive sessions. Like the first one that we had was about tough talks, smart moves, influence when it counts. So this session was actually about how we can, communicate effectively, stay composed, because tough times and tough conversations many times happen in our professional lives actually, and it actually matters there that how we thrive those situations and make our word. So the next session that we had was exploring the power of Microsoft Azure computer vision. It was by Vipul Malhotra, who is certified AZ 900 and AZ 204. So this session was all about Microsoft Azure, the certifications that you can take so that you can continue and keep learning, and master yourself with especially computer vision there. Up next, I would like to say that, anyway, as I already mentioned, here is our website, WhatsApp, and LinkedIn QR codes, where you can join us and, yes, be a part of our community. So, yeah, now today I'm very excited, and I have the great privilege of introducing you to our guest speaker, that is Mr. Yes Narsimha Jain. He is a seasoned embedded firmware developer with strong academic background and over 6 years of experience across fields like space tech, defense, medical devices, and industrial automation. His journey shows us how can one blend rigorous academic learning with real world impact. To just sum it up, as I would say that we have got enthusiastic research scientist in our house today. So that's what I can say about Jayant in all. Because if I go on, then obviously words will be less to share the across domain of the projects and the impact that he has tried to build in and provide to the society. So, and to all the students who are joining here, I would like to say that please make sure that you stay with us till the end, because a live project demo will be, actually discussed today, and it will be shown to you by Jayant. And I hope that you would actually love to have these projects, and we'll provide you with the code, with all the resources across the project, and you can yourself try it on your boards and share the results with us. We would love to do so. Also, for the all the professionals here, we will be providing you with the upcoming advancement and newest technologies in the embedded systems domain and their use cases, which you can as well use. And these all these resources you'll only get once you have filled our feedback form that we'll share at the end of session. So I would like to just say that please stay till the end, and these 2 hours of yours will be worth it, and I can vouch on it. So, Jen, are you here?
Yes, Palak.
Yeah, yeah.
Thank you for such a
Oh, yeah.
exceptional
Over to you now.
introduction.
Over to you
Thank you,
now.
thank you, thank you, thank you.
Yeah, yeah, yeah.
So I'll be sharing my screen now.
Yeah.
Uh, okay. Is my screen visible, guys?
Yes, Jen,
Yes,
it's
then.
visible. Yeah.
One second. Okay. I hope it is now too.
Yes, Jen, it is. It is.
Yes. Okay. Okay.
Yeah.
Thank you very much.
Yeah.
So, hi guys, welcome to this webinar. Today I'll be talking about mastering STM32 firmware development expertise. Okay, in using STM32 ecosystem. So this technical talk is both for aimed for both students and for the professionals. And as we go ahead, you will see how both can benefit from this webinar. So coming to my introduction, I think I don't have to give anymore because Palak has given a rather a bigger one. So I'll just sum my experiences that I have across the various fields. So I have worked in fields like optoelectronics, dosimetry, and industrial automation as well. And dosimetry, I think most of the people won't know. So dosimetry is basically comes under medical devices, and it's about the monitoring of radiation. It's about radiation physics, basically. It is used in radiotherapy to cure cancer, and optoelectronics, as you all know, it's about all about your I have developed a ECU for a wavefront sensor, and also I've developed ECUs for auto refractometers that you get to see in every specs shop. Okay, and industrial automation currently I'm working on, and I've been working on solar pump VFDs, which we have the initiation to get power to the agricultural lands that where grid don't reach. So this is something I'm working on right now, and I have a extensive 6 years experience in firmware development, and hence I thought I'll share my experiences with you. And please know that this is not a lecture, and this is an interactive session, and I would like to have as much answers from you as I can, because it's not just that I am going to teach you. It's about we are going to build an embedded system along with this webinar. Okay, so telling that, let me come to I have I have encountered a recent post in LinkedIn about embedded systems. So one of the quotes says, "An embedded firmware a developer should know a bit of hardware, and an embedded hardware developer should know a bit of firmware." See, that is what is the beauty of an embedded systems. So doesn't matter if you're a coder or if you're a hardware design engineer, you have to know both. I mean, a bit of both. So, saying that, why is that so? Now we'll come to know. So embedded system, what is an embedded system? Embedded system is basically a combination of hardware and a software designed for a specific function. So suppose if you want to take an analogy of a human body, then I would say that the whole human body, if we consider as a embedded system, then your thoughts basically are your code that you write. And if you just have thoughts and you don't move anything in your with your hand or legs, or then you don't actually interact with the physical world. So embedded system is that which bridges the software and and actually makes it access to the physical world. So the limbs basically are like your sensors and actuators and all of those things. So suppose if you want to take an example of daily embedded systems, then smart TVs, industrial controllers, or even the basic thing that you always use to go to your home as well, lift, is also an embedded system. So what is the core characteristic of this embedded system? So there are three things that are main important about when developing an embedded system, and that is it should be a real-time sensing system. So a real-time in the sense very changes that happens in real time will affect the behavior of the system, and thus what happens is you might have to think on the feet every time, okay, as you design the system. And it should be compact because you can't have huge memories intact with it. So the memory is very small, so you have to be able to write a efficient code that can fit to the small memory. Okay, and it should be efficient. The system should be efficient in the sense, suppose if you think even if with a jerk comes in a lift, you will be afraid. You will not be taking that lift anymore. Why? Because it's something that is connecting to the physical world, right? I mean, it's you are in danger if you take that lift. So embedded system also affects the real world. So thus it should be efficient in its working, and it should be reliable as well. So all these said, embedded system is a very good field that is a very good process that actually connects the software part to the physical world. So coming to that, let me tell you what are the components of an embedded system. So we have a microcontroller and or a processor, and that is like your brain basically. Okay, and we have RAM and flash. So that is basically for adding your memory. So if you write a code, where will it get stored? So you have to flash it on your flash memory, and then you will use RAM. So and then you have I/O interfaces. What is I/O interfaces? It's like input and output. So GPIO, UART, SPI, I2C, all these protocols, and GPIO basically is like interfacing with the outer peripherals. So it's like your hands and legs. It's like the limbs. So and sensors and actuators. Now, what are sensors? Basically, sensors are the ones which give input. Actuators are the ones which give output. So based on the input, you are giving an output. See, that is why I called embedded system as a real-time system that is affected by the real world scenarios. Okay, and then there is embedded software and embedded firmware. So what is people call it in their own language, but yeah, of course, there is a thin line difference between a firmware and an embedded software. But a firmware is basically a set of instructions that you give to perform a specific task. So, saying that, we can so now think, okay, embedded system is this. So does it have any, I mean, is it doing any good in the market? I mean, can I take it as a career in my life? So if you are a student, or if you are even a professional who's wanting to, some people even want to shift their field. So if they are thinking about embedded system as a field, or even a student who's aspiring for embedded system, I can say that currently the market is expected to reach 130 plus billion dollars by 2027, and that is how rapid the growth is happening in embedded systems right now. Okay, and there is a that rapid growth is because of many major sectors of embedded system. Okay, when I say embedded system, it's not just one thing, because it's a real time application. So you have categories in that, and the most booming and performing category is automotive, of course, right? I mean, everyone has a car or a bike. So and nowadays EV. So automotive is one of the very booming sectors in the embedded system, followed by medical devices and industrial automation and other fields as well. And IoT is basically like a what do you say, is more into household appliances and smart devices, and all these things contribute to the rapid growth of embedded systems in the future. And nowadays, with the exploration of AI and ML into the embedded systems, we can see that it is driving much robustly than what used to happen in the past, or in the recent 10 or 15 years. Okay, and but the thing is that we have to have some sort of skills. It demands some sort of skills from us as we go to any R&D or any product companies. So what are they and how we can acquire them, we'll be seeing in this presentation. Okay, and coming to the discussion of each and every part of the embedded system, we have to talk about the brain, right? I mean, that is what gives the instructions to everything. So, what is the brain of the embedded system? It's microcontroller, and it's sometimes called MCU. So, the microcontroller unit is basically a single chip computer. Basically, it does logical operations, and it basically computes, and it executes set of instructions. And it includes you're having a CPU, a central processing unit. It has a RAM, ROM, and it has peripherals. So what are the peripherals like? The peripherals may be some sensors, or some even a thermal sensor, or a potentiometer, anything that is touching the physical world, and it is gaining access from the user. That is a peripheral, and it's basically used for controlling the embedded system through a set of logics and instructions. Now, the role of MCU, as I told you, is to bridge software logic with the physical world. So whatever you desire, okay, like you take an example of a lift. You want something to be lifted. That is, this line is known as a in normal English, it's just a language. Okay, I want to lift something. But when you convert that into a set of software instructions and provide it to an embedded system, it actually performs it in a very procedural manner. Okay, so lifting in the sense of what velocity or what speed do you want the lift to happen, and all those factors, the real time factors affected. So that is why it is basically bridging the software with the physical hardware, and it controls sensors, the motors, the display, the communication. We can take a lift and as an example, and I can tell you all these things are there in the lift, right? I mean, you have motors to lift your lift, and you have displays in your lift. You have communications, like you press a button, so the microcontroller knows that you want to go to fifth floor or sixth floor. So basically, embedded system is found almost everywhere in your daily life. We just overlook it and we think, okay, I mean, no one gives so importance to an embedded system, but I think embedded system is the one which is the core or the background, the guy behind the screen or guy behind the curtains, you know. So, and what is the salient feature of this embedded system? As I told, it's about low power and it is deterministic task. So it will perform, a washing machine will do only what a washing machine is supposed to do. A lift will do only what a lift is supposed to do. They are not generic based platforms. They are very specific because they are, the code is built or around what the peripherals are, what the sensors are, what the actuators are, and what is the flow, functional flow. Based on this, the code is written. So it is very specific when it comes to task performance. So we have a lot of microcontrollers in the world. I mean, why do we go to why am I talking about STM32? Why not about NXP or a microchip or anything? Because STM32, as I found in my personal opinion, is that it gives you a big vast number of hardware and software supports, and it also helps you build your ideas to invention. And how is that? Because it is using a better documented website, and where you can have all the classes of STM32 microcontrollers for whatever idea you have built. So coming to that, we will see what is the families that STM32 is offering us. So when I want to say, like I want to build an embedded system, first is I choose which family of embedded microcontroller do I go with, because each project or each product demands its own microcontroller, because not every needs are one. So according to the needs, according to the functional flow, according to whatever peripherals you want to attach to it, only by deciding those you can go forward in choosing the microcontroller. And STM32 has is offering F, L, H, and G series basically. So F0 and F1 are for basic aspirants who want to work on learning an embedded system for the first time, firmware development. Specific capability oriented microcontrollers. So there are some motor controllers, there are DSP controllers. So these are very specific task based microcontroller families that STM32 is providing. And L series is basically for the IoT devices, like which dictates very less power consumption. So for those applications, you can use your L series. And H series is for like if you want to build a VFD. So you will take a microcontroller which is a very powerful enough, I mean whose clock frequency is very high, and also it has a lot of peripherals, modules in it, and also it has to have high power in mitigation. So for that you choose H series family. Okay, and coming to G, G is like the bridge between your F and L. So if you choose a G series of the microcontroller, which is very easily available in the market, so you will be able to actually learn a lot of firmware development, lot of protocols, lot of you can build a lot of projects with a G series as for POC, which is proof of concept. And if you see, look at, I mean, if you click this link, you will be able to check all the microcontroller families that STM32 is providing. The data sheets, you can go through the data sheets. As you can see, each one has its clock frequency. So based on the clock frequency, you can decide which microcontroller to choose for your project, and then you can thoroughly go through the data sheets, and then you can decide whether you want to, go with this particular microcontroller or not for your project. So coming to the ecosystem that it is providing, okay, it is providing me a lot of microcontrollers. I got it. What is next? How do I have bought the microcontroller, or I have thought about my microcontroller. How is it that I will be able to convert my idea into invention using that microcontroller? So you need tools. So what are the tools that STM32 is providing? STM32 is providing us with a very powerful tool, which is STM32 Cube IDE. So this QID basically is a combination of a platform where you can configure your microcontroller to your needs, and then you can program your functional flow as well. So the STM32 CubeMX actually is a previous version of STM32 CubeID. So what recently the STM has done is to take CubeMX, STM32 CubeMX, which is only for peripheral configuration, and add Eclipse on it. And then they created a new platform called STM32 CubeID, where you can not only do peripheral configuration but also you can do the coding as well. So that is one of the salient feature of CubeID. And coming to CubeProgrammer, so this is actually used for flashing or just the memory, access of the microcontroller or the microcontroller target board. So what this is used for is in during production lines. So you want to just flash. You don't have to go through the code, or you don't have to change any particular in the code you run. You don't have to change anything. You just have to flash into number of very huge number of sets. So for that, STM32 Cube programmer will help you do that, accomplish that task very easily. And suppose you don't have suppose I have a microcontroller. Okay, I have a board, but I want to see PWM. I want to see live data monitoring, live variables. What is the value of the variables, or what is the live PWM or sine wave PWM generation. So all these, if I want to monitor, STM32 is providing us with STM32 Cube Monitor, which can actually track all your real time data without any other particular peripheral in the middle. So you connect your PC with directly using USB cable to your board, and if you have STM Cube monitor, then you can monitor all your data live into it. So that is one of the best thing that the STM32 has done, is to build an ecosystem around it, so that or even a professional or a non-professional, a person with a embedded background or non-embedded background as well, can somehow cope up and learn how to develop his ideas into his invention or his project. So that is one of the salient features of ecosystem of the STM32. Now coming to STM32 software stack. So STM32 stack, it has HL and LLA drivers. So what is the software stack that STM32 is providing is with respect to HL, which is high abstract layer, and hardware abstract layer, and also low level drivers. So initially when I started my programming, I started programming in LXD. So there we had to write our own low level drivers as well, and then we have to create our own HL layers, and then we have to come to the functional flow. But now STM32 is doing the rest of the job for you. It's building all the foundation for you. All you have to do is paint your building good. So that is the level of support that STM32 is providing, so that a person can rigorously work on his project and get the output soon. So, and coming to the middleware, it also provides us with middleware. Middleware is basically like a layer between your firmware and your actual the functional thing. So middleware basically, it also acts like an interface. So it has USB, FATFS, all those interfaces that can, and STM32 is providing support for not only that, also for free RTOS. So in some applications, we don't go with bare metal programming, we go with RTOS. So for that, STM32 is providing the support that helps you develop free RTOS on it easily. And also it is also giving us flexibility in developing GUIs using TouchGFX. Though it is not so robust right now, they might improve in the future, but I think it is pretty good, useful to monitor your real-time data using that. So now coming to the thing that you have known all the parts of the ecosystem of the STM32, you have to decide. So as an aspirant, which one should I take? Which microcontroller board would be good for me to take and start working on the development? So I would suggest to go with STM32 G031 board, which is this, as you can see on the screen. It's STM32 G031, and the salient and feature of this board is that it is very compact, it is very basic, and it helps you with all your basic protocol learning, your GPIOs, your ADC, your DAC, all the peripherals of microcontroller can be accessed and can be worked on with this small microcontroller board. And this board will cost you around, I think, 950 or 1,000 rupees. So I think that's a very good amount of investment that you can put if you want to really start, applying for, if you are an aspirant to become a firmware developer. So if you can want to explore more evaluation boards, then you can just click on this link where you can go to all the evaluation boards that are there in the STM family. Okay, and when you go to product selector, I think you have all the the list of all the series that I showed you in the previous slides. There are series of STM32 the classes are there, and each class they have made sure that they make an evaluation board out of it. So this will help the beginner to actually put a POC on an evaluation board, test it, and then interact with the actual. I mean, make a target board and actually build from there to from project. So that is a very helpful thing that STM32 is doing right now. And coming to the firmware roadmap that I think, one second guys, I'm so sorry, my app is going down. So I have to connect it. I'm so sorry. Yeah. Uh, So coming to the STM Cube IDE firmware development roadmap. So what it does is to tell you, my aim here is to tell you how to use STM Cube IDE to, how to navigate yourself in STM Cube IDE. So if you go to STM Cube IDE, then you choose an MCU and then you configure a pinout. Then you can start writing code and then flash and then debug. So this is a very small, very nice pathway, I think, for you. But I'll show you guys how it is done in the coming slides. When I start when we'll start building a live project, then I think I will show you how we have chosen a microcontroller and how we have configured the pinouts, what is meaning of configuring pinouts, and what is how to write code. Okay, and then flashing. Okay, so this will be discussed in the coming slides. So, but the main important thing that I stress right now is to develop a modular based code. So why is modular based code important? The modular based code is important because if you write everything in just one like a project, when we make a project we just write everything in one file, all everything in one .c and .h. So you'll not be able to bifurcate between the modules of STM32 that you have used. So, or if you want to do that, you will have to write each and every module in one .c and .h. So that will maintain a readability as well, and that will also maintain ensure that no overlaps will happen, and if one module will not affect the other one. So this is a salient feature that you have to think about when you are actually starting to write code. And you have to use Git and other code management platforms to keep a track of what developments you are doing in your code and what how your project has evolved from the start to where you are now. So this is one of the things that you have to remember when you start making a firmware. So guys, enough of me talking. I think it's better to start one project, right? I mean, blah blah blah. It's enough. I think we'll make something now. Okay. So I have a real time problem, guys. I am having a problem statement that I'm not able to maintain a room temperature at a certain fixed point. Okay. So this is a real time problem. And is this problem just a thought experiment or a question in a question paper? No. So there are real time areas where you encounter these problems, like clean room facilities or R&D labs, or even your where you keep servers. So it heats up, right? When a lot of heat is generated, you have to make your room to have certain temperature. So if you want to maintain your room at 20 degrees, so how do you do that? Of course, you install ACs. That's the basic. But how do I make sure that all ACs are running at the proper manner so that the temperature is always around 20? So this is the problem that we have encountered, and we will be giving a solution to this. Okay. So coming to the solution part, and also if like what would be the functional requirements of this, like if I want to have the smart AC controller, what would this be expected to do? It is expected to have a knob. Suppose you have set a set temperature, right? So if that temperature, if the ambient temperature, which is room temperature, is going above that above 10 degrees in the difference, then you have to rapid cool the room to get it down to the fixed point. Or if it is just around 10 to 3 degree, 3 to 10 degree, it is between that, then you will be not having a rapid cool, so you will be running the compressor, which is the cooling system, at 50 degree, 50% of the rated speed. And when it is in just 1 or 2 degree, less than 3 degree and more than 1 degree difference between the set temperature or the desired temperature, then you will be going with idle mode, where it is running at very low speed. Because if you do a rapid cooling, or if you keep doing rapid cooling, it might come down, the room temperature might get down to the what is desired. So that is also not desired from us. So we don't want to get it down, or we don't want to keep it up. We want to keep it at that fixed point. So this is the functional requirements, and that is the problem statement. So how do we tackle this, right? So we want four major things in this smart controller system, smart AC controller system. So what is that? So as in the requirement sheet, it was written ambient temperature. So we have to think, okay, ambient temperature. They mentioned about ambient temperature. How do I do that? So I install thermal sensors everywhere so that I can somehow map the ambient temperature of the room. Okay, if you just keep it at one place, I don't think it will, it is sufficient to measure the whole room. So you will have to place it. So you have to think this as an embedded engineer. You have to think how to give a solution to the real time problem. So just making a project, okay, I did. Okay, I have to think about sensing the temperature. I did. So that won't actually fetch you any good. So you have to think around about a real time situation here. So we have to have a thermal sensor, then we have to have a temperature valve. And now why is temperature valve important? Because if I start cooling it more and it gets down the fixed point, then I have to start heating it up, right? I mean, I have to go back to that. If I have to say 20 degrees and it comes to 18, then how do I get to 20? By heating it. So there should be a valve which will shift from hot air to cool air. So this valve is also should be controlled by the microcontroller. And then there is a knob which can set a particular temperature. So that will be a basic potentiometer. You can use a basic potentiometer to as a knob to set an analog temperature. And then we have to have an AC control unit, which is like your it comprises of your compressor, and it actually takes input from you about the motor speed that is mentioned in the functional requirements. Correct. So all these peripherals are required. And now, after knowing these peripherals, we have to know what is the way we interact with these things. These are physical things, right? I mean, a potentiometer is a physical thing, a temperature sensor is a physical thing. How do I get it to talk to my microcontroller? That is the main aim, because unless you do that, your microcontroller won't be able to do anything for you. So we have to think of the nature of the microcontroller. So nature of these peripherals that can be interfaced with the microcontroller. So can anyone tell me, or you can just write it in the chat box, what is the nature of this? No, so nature in the sense, are they analog inputs? Are they analog outputs? Are they digital inputs? Are they digital outputs? So classify into all these four peripherals into these categories, and you can write it in the chat box, and so that we can interact during this project.
Yeah, yeah. I guess we are getting few people are typing in the answers, and we can get the answers from there. They are taking some time. Let us give them some time.
Yeah, sure.
Yeah.
I'll just check them.
Yeah.
Yes.
Vamshi Krishna has actually answered that temperature sensor will give us analog output, and that is correct actually. That it will give us analog output.
Absolutely. Yes.
Yeah. Correct. Will not have any digital inputs as for here is what the answer that I can give. And we'll also use one, I guess, ADC converter, because we have to give the temperature sensors input to the system, and from there we have to receive back the signal and give the output as well back to the analog thing. So I guess that one thing will also be happening.
Yes. So what about the potentiometer, guys? Is it an analog? Does it give an analog output or a digital output?
And they have even given about, I guess, one more answer is related to analog thermal sensor itself.
Yes.
That it's analog. Yeah, correct. You're right. Harsimran, as well as Vamshi Krishna is also right.
Of course, you're right. Potentiometer does give analog output. So, do we have any digital based here? Can anyone point out any digital here? Digital inputs, digital outputs. Palak told there's no digital inputs.
Yeah, I guess there won't be.
Is there a digital output here?
Potentiometer also gives analog input itself.
Yes. So I think control. At every increment intervals of time, and it will generate a bit again, right? I mean, just up down. But then there is also a way STM32 makes it an analog output. So that's interesting thing. Okay, so the width of the pulse, right? Now that is an analog, right? I mean, it's if you say on time versus off time. So on time, suppose for 100, if you have 100 and 95, 89, STM98 is an actual analog. It's not digital, right? So the width of the pulse is actually can be configured like an analog, and then we can use it to put out as an analog output. And I'll show you how it is done in when I show the code and everything. So I think we are good to go, Palak. We'll continue with this. Okay. So it's a good answers, guys. So coming back to the presentation, yes, you guys are right. Okay, it's digital inputs, as Palak pointed out. Well, digital outputs, what everyone forgot, is temperature valve. So temperature valve is basically a relay. Okay, it's an open shut, open shut. So a relay is basically a digital output. Okay, and thermal sensor and temperature knob, as told by many people, it's analog input. Very good. And there is analog output, as I told, speed control with PWM. Of course, you can argue that it's a digital output, but I would like to make it as an analog output using STM32, mainly because if you say digital output, then you have to create a PWM with using high and low. You have to pull the GPIO high and then low at certain intervals. And if you miss that interval, if there is any other function which is messing with it, then all your PWM is gone. So it won't perform the way it should perform. So it is better to have a internet based configuration based output, rather than we forcing a pin to go high and low at certain intervals. Okay, so coming to that, I will again tell that, as Palak also told. So for analog inputs, what do we need? What is the MCU peripheral that we need? ADC. So STM32 has an internal ADC that can, and it has a ADC pins for which you can give your analog input, and then it will convert it into digital output, and then you will get the values in your code. Okay, and then you can use timer. Okay, basically you can use a timer in interrupt mode as a PWM generation. Okay, and that I will show you guys in STM32 how it is done. I'll show you, and that will be our analog output basically. Okay, and I'll also justify how it is an analog output while I'm showing the code. And we have digital outputs, and for that we can use the normal GPIOs to go up, I mean to shut or open the valve. So what now I want to build a project. Okay, I have analyzed my, I have the functional requirements. I have analyzed my, what are the modules that I would require from the MCU. So what to do next? So next is to go back to the STM32, microcontroller section and choose your right MCU. So you know what all is required here, right? You have a digital output. You want GPIOs, you want ADCs, you want timer. So even a basic, I think even on G031, which I showed, I think that will also justify your project, and that will can also handle your functional flow. So after that, what we do is we go to selection of board, because okay, I know I have chosen my microcontroller. I'll not start designing my end, board, target board or control board without having any proof of concept, right? We have to attain a proof of concept that yes, whatever I have thought will work. So for this is why STM32 is giving you evaluation boards to test your POC on that, and if it is working, then you can go and invest in making your own board that will accomplish all these tasks. So then you build a flow diagram, right? I mean, you have to have this, what is that? A flow chart basically of what to do and what next. So based on that, you will create your code in STM32 CubeIDE, and then you will flash it, and then you will start debugging the code, right? And then when you debug your code and everything is running fine, all the functional tests are done, that is when you can say that I have my POC. Okay, what is a POC? POC is basically a proof of concept. So a proof of concept only justifies your functionality in certain test cases. That's it. So it has not yet you have not yet rigorously tested your um, board or your project in different conditions and then justify saying that yes, this will work and I can certify it, right? So that is what is basically a POC. Basically, POC is a starting stage of your project. So coming to the best firmware practices that is possible. So as I said, see, you might actually feel like, why is this person actually repeating this thing? We have already had the roadmap. Why again? Because usually when a person starts doing a project, he is in such an enthusiastic mode he forgets to actually follow set of rules while he's writing a code. Because after 10 days, if he writes a very bad code, I mean very a code in a very bad manner, then after 10 days he himself forget what he had done and where to take this from. So if he wants to build over that project, new add-ons or new features, then he'll not be able to do that. So it's better to again remind ourselves that we have to have a modular design of the code. The code must be modular based, and it should have separate drivers, logics, and configurations to it. Like it should have a difference between the logic, the low level drivers, the HL drivers, the functional functions, the function flow functions, basically. So all these things must be taken care of. And use Git always to, if you start a project, immediately start having a repository in your Git, and then you keep pushing it to the Git every day. So when you want to work next, you will have an idea where you started with, and when you push in a Git, you make sure that you write proper comments so that you will know what you have started from and where you are going. Okay, and use debugging tools very effectively. So use breakpoints, use all live data monitoring, global variable monitoring, so that you can justify that yes, whatever I as the number that is supposed to come, so it is coming, I mean, it is happening or not. So if I say that I will be able to generate a PWM of 95% duty cycle, so you will have to know whether it is how accurate is 95% of your, and how much dead time do you have, how much of lag do you have. All these things can be monitored properly using proper debugging tools. Okay, and then one of the important thing that most of the people forget to do is to write comments. Sorry. So I have seen people who are writing very good code, but they don't write comments. So that will be a problem to the next person who is taking over your project, right? And for him, it is all gibberish. So to avoid that, what I would suggest is to have one line or at least a small line of comment, okay, at every instance, which actually impacts the code. So that way you can build a readable code, and that can help your next person who's taking over the project, or who wants to even like there are some open sources, right? You will want to submit your part of your feature to that project. So if you want to do that, then I think having comments in your code will help a lot. So now, guys, I think uh, before we go to the next part of the presentation, it's better I show you the code that I've developed for this particular project. Okay, so this is STM32 Cube IDE. Okay, and if you start the Cube IDE, you can download STM Cube IDE using the link that I've provided in the tools ecosystem tools. So that will help you download the Cube IDE. And once you download it, you will have to log in. Okay, because if you don't log in, it will not accept your I mean, it will not let you flash your firmware on your board. So that is some new thing that they have recently introduced 2-3 years back. So they want every registered user only to use their platform. So you have to register yourself into the STM QID, and then you can start with. So this is the structure of your workspace. So if I created a I think Palak, everyone is able to see the screen, right?
Yes, yes, everyone, like I can see the screen. I guess everyone else is also like they can see the screen.
Yes, yes. Screen is very
Please?
clear.
Yeah.
Sorry guys, I'm a bit unwell, so बीच बीच में ये होता रहेगा. So
It's all right.
yeah,
It's all right.
yeah.
Yeah.
Coming to that, so this is a workspace. Okay, so your workspace has these five generated already to you. So this is an IOC file. When you click on the IOC file, I mean, when you start creating a project, when you choose the MCU, target MCU, it will load your IOC file basically. So how your IOC file looks like is in a moment. I think it's taking a moment. Let's pause. Because it's a graphical file, it requires a bit of time to actually load. Even first I thought of creating everything, but then you have lot of tutorials on YouTube where you can go and actually see how to create a STM32 cube ID and everything. But my point here is to show how to build a project or how to use STM32 ecosystem to bring your thoughts into an action. So that is what is the main motto of my presentation here. And yes, it is loaded. Okay, I think everyone can see this. So this is basically
Yes.
your MCU that you have chosen. Okay, so it is STM32 G031K8, the exact evaluation board that I have shown you people. Okay, so if you go there, then you can select a pin. Suppose I want to configure a GPIO output. Okay, I can click on the pin. I can say GPIO output. So it will assign this particular pin to GPIO output. And if I want a ADC, right? So I can go and select ADC. So there is only one ADC in this because this is a very basic and floor level IC from STM32. It has only one ADC in it, but it has 10 to 15 channels in it. So I can choose ADC 1 in 7. So you don't have to go always with in 7. You can choose other pins and you can see that the different channels of ADC are available. So it is your convenience to choose whatever channel you want. So you can just go there and choose ADC. It will configure that pin as an ADC input. Okay, then what more you want is a timer, right? You want a timer. So you can use any timer. Suppose here there is timer 3, channel 3. So there are a lot of timers here. You have almost, if you go here, you'll see that you have a lot of timers here. So you have time 1, 2, 3, and 14, 16, 17. So these many timers are available. Almost 6 timers are available here. So you can choose any one of them. And I have chosen timer 1 because timer 1, 2 only provides you with PWM generation. So I have done all this and configured it. So I will not configure it now. I will just reset it because if I don't reset it and if I press Control S, it will generate a code based on this. So we don't want that. So I'll just reset it back. So see, even though if I remove it, it will ask to whether I have to generate a code. So after you configure all of it, you can just press, yes, generate code, and it will generate a basic code for you. And you will have to write in the place where it is written, user code begin here. So if you write in that place, your code will not get erased next time you change any configuration. Suppose you don't write in those particular places, what happens is when you go back to IOC, you want to change something, right? And then when you are changing it, and then you generate a code, it will erase all your code and it is not retrievable. You cannot retrieve your code back. So be very careful when you are actually writing the code, where you are writing the code in this whole script. Okay, I'll show you that as well. So coming to this IOC again back. So now know how to choose your pin configuration, right? Now you can go, you can set your clocks here basically. Okay, you can set your clocks. It is at 16 megahertz. Okay, the clock frequency is 16 megahertz. So what I did is, so I want to generate a PWM, right? So now this is an interesting topic that I want to stress on. So timer, what it does is, If I go to timer 1, so I can choose the channel, right? I have chosen as timer channel 1 here. This is timer, where is this? Here. So timer channel 1 is what I've choose. Timer 1 channel 1. So timer 1 channel 1, I have given it as PWM generation channel 1. So it will do other jobs as well. We just have created for generating it as a channel 1. PWM generation. So coming to this, when you go to parameter settings, right? If you see here, so we have to scale this clock. The clock is 16 megahertz. So you will have to scale it back to 1 megahertz. If you want 1 kilohertz or 1 kilohertz or 10 kilohertz frequency of the PWM, how to create a 10 kilohertz frequency PWM is by clocking it to your 16 megahertz to 1 megahertz. That you do by dividing it with 16. So we have done that. And minus 1 is because this register takes everything plus 1. So 16 minus 1, so it will take it as 16 at the end. So what is the counter? Counter is basically how many times it goes for 1 megahertz, right? Again, 1 megahertz is divided into 100. So it will give you, if 1 megahertz is divided into 100, it will give you 10 kilohertz of frequency, right? So, but what is the another salient feature of this counter is this is where you put your percentage of your uh, pulse width. So if I when I told you that I want 95% motor speed, so all you have to do is there is one more register. There you can equate that register to 95.
हाँ जी सर
95 by 100 by this register. So it will become 95%.
दो जोड़ी थे
Okay, so that is this whole settings that you have to do in timer so that you can generate, PWM using timer
नहीं यार
module.
नहीं था
Okay,
अभी मेरे पास अभी भी मेरी ड्रॉ में रखी
so
हुई है
coming back to
cupboard
the
में
code.
कहोगे तो
Okay, so this is the main
मैं
structure,
ROM को
main
खोल के क्योंकि
part of the
छुपा
code,
देती हूँ उसमें 4-5 प्लेट्स
main.c.
थी
Okay, you can create again. You can create a lot of sub modules. I don't want to create that because if I do that, then it will be a lengthy code. So for a pseudo code, I'm just
मैं एक
building
बार
it over here. All the peripherals
एक बार
I'm
रीचेक
building it
करा
over
लेती हूँ
here.
यार
So as you can see, I have written the code. These are the variables that I've macro defines that I've used, but I've used it in under the begin.
अभी
Code
मत
begin
भेजना
PM.
अभी किसी
So
को
if
मत
I
भेजना कोई नहीं
don't
मिलेगा
write it here and then again I generate, suppose if I write it somewhere
मैं
like
एक बार घर पे पता कर लेती हूँ
here,
कि
I write it
घर
here
पे सब
in
कितने
this
बजे
line.
आएंगे
I push this
तो
here
मैं
and then I
मैसेज कर
regenerate code. All these code of mine will be erased. So take care of that and make sure that you write the code at proper places. Okay, now coming to the
मैंने
main
तुम्हारा
function,
लुक
right?
जब
So
तुम्हारा
a main
था
function
ना
of the
मैं
firmware
तुम्हारा
has
पूरा
one
प्रॉपर बैग लेके आई
time
थी मैंने उसको एज
executables
इट इज लाके
and
किसी
n
किसी
time
जगह किया था
executables, right?
इट्स
So
अबाउट
in
5
one time
kb
executables, I
ठीक है
initiate all my
तो मैंने
modules,
क्या किया
which is
मैंने उसमें दो
GPIO,
पॉलिश थी 100
and user
तो
it is
मेरा
by
लगेज पैक
default
नहीं हो पा
it
रहा था
does. So
मैंने सोचा मैं
you
थैली में
don't
से
have to
निकाल
worry
के
about
ना
that.
उसको
And then
फोल्ड करके
an
रख देती हूँ तो
ADC
छोटी
and then
चीजों में
one
पैक हो
timer.
जाएगा
So we have
उसमें 2 पॉलिश थी
showed how to
जब मैंने निकाला तो उसमें
configure an
प्लेट्स
ADC,
थी
how to configure a
मुझे
timer,
ही डिडंट
and how to
इन्फॉर्म मी
configure a
उसने मुझे बोला
GPIO
इसमें
because we
कपड़े
have
हैं
to control its
सोप है
in and
पानी
out.
है तो
Okay,
मैंने बोला ठीक है
so and then
उसके
what
बाद
we
में
do
मुझे पता
is
ही
we
नहीं था
start the
जब मैंने प्लेट्स देखी थी मैंने
ADC.
तुरंत
We
आपको
start
कॉल
the
किया मैंने
ADC,
बोला यार
and
इसमें
when we
प्लेट्स क्या
start
पाई
this, it starts sampling the
मैंने सेम
input
टाइम को आपको कॉल किया था
variables. Sorry, input voltage, and then we have timer PWM start here. So
मैंने
what this
ऑनेस्टली
does
बोल
is
रही
to
हूँ मैंने एक
basically
पॉली
it
खोली थी जिसमें
starts
प्लेट्स थी
your
जो जिसमें
PWM.
मुझे कुछ अजीब लग रहा
I
था
mean
क्योंकि वो
it gets
फोल्ड
it
नहीं
you
हो रही
ready,
थी
and once you input the duty cycle percentage, it will generate the PWM
हाँ
accordingly.
तो हो सकता
So
होगा
coming to
क्योंकि वो
the
मैंने जब
end time
देखी थी तो
executable.
प्लेट्स के लिए
So
मैंने आपको
why
तुरंत कॉल किया था
end time?
मैंने
Because
बोला यार
this
इसमें
is like
प्लेट्स
every time you have to check it real time.
अरे
This is what
नहीं
I'm talking
यार
about. So
बाय
every
वर्ड
time you
ऐसा
have to
कुछ
keep
भी नहीं
checking
है पागल हो
what
गए
real time scenarios
मैंने
is affecting your
नहीं
code. So these
तुमने
are
जो मुझे
the parts which are affected by the real time. So ADC
तुमने
value
मुझे
is a
वेट
real
के लिए
time
बोला
thing,
था
right? I
मैंने
mean I
अपना
can
वेट
change a
चालू कर
knob
दिया था
and
सेम
I can change the
मैंने
temperature
अपनी
anytime
निकाल दिए थे
to whatever I
जो
desire.
मुझे
So when
जो
I
मुझे
change it,
कपड़ा में रहने थे
it should be able to
मैंने
take
वो
it
कपड़े
every
नहीं
time. It
निकाल
should be
दिए
able to update itself every time. So we will be writing that in the while one. And so this is the pseudo, not a pseudo code, but this is an actual code.
मैंने
So this is the
वो सारा
logic
सामान
behind what is
मेरे
the
कबर्ड में ही रखा है मैंने मम्मी को बोल दिया
the
था कि
requirement, the
सारा
functional
सामान एक कबर्ड में रख
requirement
देना
that we will be having. So if you see the if you go
मैं
back to
अभी
functional
थोड़ी देर में
requirement,
बताती हूँ आपको
you can see that I want the ideal state When it is less than 3, I mean it is less than 3 degree and it is greater than 1 degree, right? If the difference is greater than 1 degree and less than 3 degree, then I want it to run in ideal state. If it is less than 10 degree, okay, if it is less than 10 degree and it is less than greater than 3 degree, I want it to run in eco state. And if it is more than 10 degree, then I want to run it in boosted. So all these things depend on the ADC value. The ADC value is basically the you can also say that this is like if you configure two ADCs, one for knob and one for the temperature sensor, then this is the difference of those two values, and it will decide so which mode should we go for. And once you do that, you decide the state, right? Once you decide the state, you can use a switch case basically, because in if loop, you have to be very less, you should write as less as possible in an if loop and use switch case instead. I actually advocate for switch cases over if loop anytime. So I have three states, okay, eco, ideal, and boost. So once the state is chosen based on the ADC, I will be doing two jobs first. One is to run the PWM, right? So this CCR1, this is the register which takes the input of what is the percentage of the on PWM on time that has to be there, and this basically divides it by the ARR. So in suppose if you put in ARR, if you put 1000 - 1 instead of 100 - 1, okay, then what happens is it will take 9.5%. So we have to be very careful of how we configure the auto register there and the CCR1 here. So that is very important in this matter. And once we like for every state,
Oh yes,
we are
that's totally fine. Even I
putting
have a same
the
problem when it is agarbatti smell.
the percentage of it.
I understand
And
those things.
we are
Means
also
it's also like even
the
I have a
writing
problem with
the
the
pin out
heart
and
fitness and
open and
all.
shut.
So
So if you
I try to
see,
ignore all these things. Don't worry about these things. Yes, I'm typical Hindu, but I know how to adjust
so
my
if you
things. I
see,
will
sorry guys.
do like these
So if
things.
you see
Understand.
the GPIO is open. So when it is open, it actually lets your cool air, and when it is closed, it actually lets the hot air. So in ideal state, you don't want it to cool it rather less, right? So what you want is to open it, and you want it to sorry, when it is open it is actually leaving hot air, and when it is closed it will leave you cold air. So what happens is when you're opening it, it will keep the heat also in the proper way, such that you don't actually push a lot of cool air and then you get down the set knob condition. So this two things are what was discussed in the requirement, that you have to maintain certain speed of the AC, and then you have to maintain your temperature valve to not get down or get go up of the certain fixed point. So by this you can make sure that when you connect the peripherals, okay, since I don't have all the peripherals, I'll not be able to show a live demo for you as per C. But then this code, if you take this code and if you run it, and you can explore yourself how you are able to build a smart AC controller by which actually follows the set of instructions that is provided in the requirement. Okay, so this is the code, guys. I think I'll be providing the code in the end. So be sure to stay so that you will be able to get the piece of my code as well. Okay. So coming back to the the presentation. So now we have a working the project. Now we have completed our project. The smart AC is working. But how do you define a working, right? I mean, is it always working, always not working, or sometimes working? How many times have we tested
भैया
it,
मम्मी
and
से
how do
पूछ
we
लेना
test
अभी.
it? So all these matters, and all these are the ones which differentiate
मम्मी
a project
मम्मी
from a
वो
product.
जीशान का जो सामान
So
है ना
if you are a person who is aspiring to
मम्मी
become
उसमें
a
कितने
product
सूट है.
engineer, a product developer, or a product company, firmware developer in a product company, then I think
वो मेरे
it
को
is
सुना
good
रहा
to
था वो
have all this
फोन पे
knowledge, because when you
कि तुम्हारा
show
सामान वाले
that
दिन
you have
डिलीवर नहीं
a
था, मेरे यहाँ पे
foresight of
अभी भाई किसी का
a
तो भाई ये
complete
वो
four dimensional flow of your project. I mean, or you have thought of
उसने
it
कुछ बोला नहीं।
in all the time cells. Then people will be very intrigued and they will be interested to take you, and you'll be able to work in big MNCs or any product companies that you aspire. So, so basically,
522
sorry.
थे उसमें।
What is the
वो सही
key
बोल रहा
thing
था कि
that
522 थे।
differentiates a product
पहले
from a
दिन में
project
काउंट
is
और फिर बोल रहा
usability
था कि
and
522 मैंने
reliability,
बोला
as I told.
522 तो नहीं
So
थी।
usability.
वो
So
थे
what
नहीं
are
थी,
the
पहली दिन गलती
conditions
थी।
in which the
इतनी तेज थी।
usability is
ठीक है
true, and what are how reliable is this? So
वो
the more
मेरे को
we
भेज
test
रहा है
it,
घर पे
only when we
सामान
subject
के
to
लिए।
rigorous testing is when we can
कप्तान कब
assure
आएगा?
usability and reliability. Okay, and product
कल
must be
आएगा।
repeatable.
कल कप्तान आएगा
Suppose
ना तो
I
कप्तान का
make
नंबर ही दूंगी तुम्हें।
three sets of my
कल
own
मैं मॉर्निंग
board
दूंगी।
and I
वो
give it,
फोन करेगा ना
and but
लोकेशन के
in
लिए।
every board I am getting a
नहीं तो
different
कप्तान को बोल देना पेट्रोल पंप
output.
तक
So that
जाएगा
is
ना तो
not
वो दे देगा वहां
actually
तक।
that is not a way of
हाँ
making a product, right? I mean, product
ठीक
in
है।
the sense every product. So if I buy three
वो
Google
कल कप्तान आ जाएगा
Pixel
ना तो मुझे
phones,
बता दे, मैं
everything should
करूंगा।
work in the same way. Three phones cannot work in three different ways because that would not be called as a product. So that is very important. It should be testable. It should be manufacturable.
ठीक है।
Okay. What are those? We'll discuss in the later slides. And it most important thing is it needs documentation. So you should know where you started it and what are the features that you have added. What did those features, benefit you, or did they actually cause any trouble during your functional flow? So all these must be thoroughly
मैंने बात की
documented
तो घर
so
पे
that
कोई है नहीं।
there is a
कल
maintainability
घर पे सब
in
आएंगे
your
ना तो
product.
वही
So
पेट्रोल पंप
coming
पे
to
ना
that,
कोई डिलीवर कर देगा, आप उसको बोलना वो वहां से पिक कर
we
लेगा।
have a definition,
I'm
a small definition of your product,
कल
which is
आएंगे, कल
engineering for
आएंगे,
real
वो
world
घर पे है
development,
नहीं अभी इस समय मेरे पास।
deployment. Sorry, because project is something that is personal, but a product is something which is
आप मुझे
worldwide. So if you are deploying
मैंने
something into the real world, you need to
हाँ मैंने
have
मम्मी को
certain
बोल दिया
things
है, मैंने मम्मी को
already
फोन कर दिया है।
taken care of
मैंने बोल
so
दिया
that
मम्मी कि
your
एक बार वो
project
पूरा बैक
is
चेक कर लेना,
now a
मैंने उन्हें बोल
product in
दिया
the
है कि
world.
इसमें 4
So
या
what
5
are
परसेंट
those? For
बकाऊंगी
an
बताना।
electrical or an
मम्मी को बोला
electronic device, the main thing is
आप
EMI
उसको
and
मुझे फोटो
tolerance,
भेज दे,
thermal
आप मुझे
tolerance.
फोटो
So
भेज दो
EMI
घर
and
पे भेज के।
EMC, basically electromagnetic interference and electromagnetic conductance. So these are the very basic starting level testings that you have to do and you have to pass in order
अरे
to
पागल
have
हो
a
गया है।
proper and thermal emission. How long if I put this thing
अरे
on?
तुम
So
यार मैं
smart
किसी के
AC
साथ
controller,
जाऊँ
right? I
बताओ,
mean, if
तुम्हें
I'll
लगता है
keep that
तुम्हारे काम
on
के लिए
for
मना करूंगी?
a day, or
आज तक तो
I
मना
mean,
किया है।
continuously
अगर
it's on in
अब
industries and all, they don't off it. So how long can it survive? Thermal tolerance, how good is it? So all these things are something should we have to take care of.
नहीं
And firmware stability. So how many errors did we handle? How many errors
नहीं ढूंढ पा रही,
came up
परेशान
during
हो गई सामने
debugging?
वाला बंदा
And
और
how did we encounter it? Is there a proper documentation or proper
कोई नहीं।
firmware flow that has
कोई आ जाएगा
encountered all
मेरे घर
these
पे
problems?
कल
All
11
these have
बजे,
to
सब आ
be
जाएंगे
taken
11
care of.
साढ़े 11 बजे।
And one more thing is after
जिस
that,
दिन बस कोई
so
आएगा
once
मैं
your
बता दूंगा, मुझे
testing is good,
फोटो
your
भेजना, मैं
firmware is
मम्मी
good,
को भी फॉरवर्ड कर
now we
दूंगी।
have to go for compliances. So what compliances do is if you are developing a industrial product, then you have to have industrial grade standards met. If you are developing a medical product, you have to have certain medical ISO standards met. So all these compliances ensure that it is properly standardized and it is according to the standards and it is good to go in the market. Okay, and so and one more thing that I have encountered in my experience is that there need to be a proper packaging and enclosure. This might sound very non-technical, guys, but believe me, this is a very important thing. Okay, because no matter how robust is your inner board or your firmware is up to the mark, I mean it's robust and boosting, but if you do not have a good proper mechanical cover for that or a mechanical setup for that, and you don't properly package and then the enclosure is not good, then the first impression is always going to go bad. People will look at it as a second rate product. So make sure that you also invest some time in ensuring that the enclosure, mechanical enclosure and packaging is done proper. And these are the things which make a project from a product, I mean, a product from a project. And then this product is actually welcomed in the market very nicely. So next, coming to the productization essential. Okay, now I've decided to go for making a product. So what are the things that I have to keep it in mind? My what are the so I want to build a lot of AC controllers and I want to spread my wings. So in order to do that, what you have to first or any company does is to first cost optimize their BOM. So because if you're suppose if your board is costing you 10K and you are selling it even for 15 or 20K, over on a big scale, if you see the margin is so small that the profits that you will reap is not in the near future. So you need to think about BM optimization of how to talk to the vendors who provide us with all the the good products, and then we have to also think about PCB revision. How many times did I change my PCB? How many times did I affect its manufacturability? So all these things should be taken care of, and it also ensure that there is a product grade components and connectors that are there in your project, because during project you will not be thinking of that, but during product you have to make sure that it is going to be a production grade components or even the ICs and everything. Okay, so and then how do I ensure the flashing or bootloader strategies on the product line so that my more number of products get into the market. So this is one of the important things. Okay, so also if you think of scaling to from lab to market, then you have to think about all those prototyping tools versus production tools. So because prototyping tools might not be the same for the production tools, and some jigs and manufacturing diagnostics, how to optimize your manufacturing process or all those things. So basically, what you have to do is to understand that in order to go to market, you have to think thoroughly on all the stages of product development. That is how you ensure that your product go good in the in the market. So what is the key mindset that has to happen in students or and developers for gaining a going ahead with the product from their project is to think that it's not going to just work once, it should work all time. So that is the first thing, and then you have to emphasize on the proper maintainability of the product. You have to think about collaborating with other teams like QA, which is a very important role. They ensure that your product has a quality in it, and they help you with all the compliances and everything. So all these things has to be shifted in a student mind for and the developer's mind in order to get the project into a product. So what are the embedded core companies now? Okay, now you have all the attitude built. Now, what are the companies that are giving me opportunities? So if you see this, I have listed out all the companies that are and based on the sectors in embedded system. So if you are going for core semiconductor or automotive, aerospace, defense, industrial automation, healthcare, and startups, all these companies can help you give opportunity for you to become a firmware developer. So go through it, guys, and then you just you can apply it, and you can excel in that. And skills required for an embedded firmware roles in order to apply is basic proficiency in C. That is like the basic one, and I cannot budge on that, and no one can. Then you have to know how to read data sheets, because if you want to do register configurations, if you want to know pinouts, all those things, only an MCU data sheet can help you, and you have to know how to read it thoroughly. And coming to communication protocols, you need to know basic communication protocols like UART, SPI, I2C, CAN to minimum interface it with the one-to-one board or one-to-one units like that. And you have to know some debugging tools and logic analyzers, use oscilloscopes, because embedded is not just about firmware; it's also about verifying it on the hardware. Okay, so you have to know all these things. So you can start with brushing up with C fundamentals, then going for the bare metal debugging, then starting up with Arduinos. Then you can go on, practice the board level debugging, then problem solving, like how to improve your logic, and also keep ensure that you have coding in GitHub. That GitHub link is there on your resume. What this does is to help you build your portfolio. So if your portfolio is good, so when you document your projects, you show your schematics, you show your code, you show your video photos, then what happens is reviewer already knows everything you have done. So you will great job. So he will not start. He will take your time with starting with small, basic level questions. He will already start asking you a project level question. So that will actually give more chance for you getting to know more people. If you do this kind of documentation of your project and use GitHub repo as a badge, and throw your projects out in the world, help with open source software libraries, and then you can take also the internship at companies, R&D startups, if you want to keenly become an developer. So there are also some certifications online you can go to in Coursera and Udemy, like RPAS or UX, leading for STM developer. And if you see, not just UX systems, UX systems design, it is all based on the applications. You will have to have some amount of domain knowledge as well. So for that, you can go to IIT Delhi, and you can, if you are working in optical electronics, so you will have to have some knowledge about it. If you are working in university, you will have to have some knowledge about application physics and mechanics. So you will have at industrial application, you have to have some knowledge about electric drives. So all these things can be helped from the IIT and IIT courses. And if you want more firmware development help or support on those kind of courses, then STM is having its own training program in ST.com. You can go there, you can search for your whatever the certification you desire, and then you can do it. Okay, so coming to the recap, guys, I think we can have a recap about whatever we have discussed. So in the STM32 ecosystem, we saw all families of mixing and all development tools that help you build your ideas in invention. And real-time industrial support is also given in STM Global. And if you see our projects, it has what insights you can get, and how STM32 helped you solve a real-world problem, and the importance of firmware and modular coding, firmware practices, how debugging and documentation, all these things, why they are important. So I think, guys, I've given a good amount of time, guys. I think I can open the stage for some questions. Karan, what is it?
Alan, not audible, but yes, the overall session was very nice, detailed. Alan is still not audible.
Thank you, Piyush.
No, Alan is joined. So, overall session was very nice. Any question from anyone? Like, how to build career, or they are looking for placement advice, anything which anyone wants to discuss? Okay. Jim, do we have that feedback? You are also in this?
Yes.
Okay. So request you all, Jayant worked so hard. Even we also tried so much on marketing and operational efforts. So we request you all your feedback. Just scan this code, and if you need link, I can post you the link also. Just give me a minute. There is a link also if you want. Let me paste it in the chat. Till the time we can discuss that if any of you are expecting any kind of a specific question or a specific session you are looking for, just one more thing I want to give you a little bit additional add-on, that next event around July, which is the second week of July, we are planning an event on Salesforce. That is 12th of July. We are planning an event on Salesforce in which we are giving the complete detail about the Salesforce, that how you can build your career in Salesforce, how you can start your certification, because Salesforce right now very popular in market as a CRM. Like Cars 24, Electronics Art, most of the big companies are using Salesforce as their CRM. So just want to inform you. But regarding this session with respect to the embedded system, like Jayant as a scientist shared a lot of details with us. Any questions or anything which we want to discuss with Jayant?
I think Rohit is guiding.
Sorry, Jayant?
Rohit is guiding. I think Rohit can go ahead.
Hi. So my question was, so the entire session was basically quite simplified. It was helpful for someone like me who does not hold a background in embedded systems. So the question would be, Jan, the PWM conversion from digital to analog that you had explained. Can you reiterate?
Yeah, sure. So what has happened in the PWM? So if you see a PWM, we see just that it's going high and coming low. It's just high and low, a series of high and low. But when we focus on the breadth of each PWM, so that is an analog one. So if I want, suppose if I have in 1 second, so I have 500, if I say 50% duty cycle, then I will keep my on time as 500, off time as 500, right? So if I want to decrease it, so again if I say 45%, so 450 on and 550 off. So if 450, 550 and all these things are actually an analog one. It's not a digital one. It's not just high and low. It's not just 1 and 0. It is a number. So a number is an analog one. So STM, what I've shown in my code is that with that register, basically the timer register, you can actually make a PWM act like an analog one. In the sense that the PWM itself is not analog in nature, but the width of the pulse, each pulse, is analog in nature. In the sense the width number, the duration is analog, not the pulse width modulation is.
That really helps me. Thank you.
Thank you. Palak is still not audible.